Okay, so, hey, I'm recording. Shh. So this is objective 1.2b, linear applications. That's word problems for linear equations. And you will be successful when you can model word problems as linear equations in slope-intercept form. Okay, so let's take some notes here real quick. Question. It's frozen, so that's not helpful. How about I unfreeze it? There we go. Thank you for that. All right. So some things to write in your little notes section that I think will be very helpful, other than to remind you that to write the equation of a line, you need a point and a slope, which I just told you a little bit ago, is this. Two variables are, in all caps, linearly, there's an adverb for you. It's not even easy to say. Linearly related. Basically, the two coordinates or the two variables have a relationship in that when you graph them, they make a line. That's the relationship. Okay. If y equals mx plus b, our slope-intercept, and m is not 0. And it's certainly not if it's undefined, but that's not a real number. And we're talking about real numbers. Okay. Things to be on the lookout for. Look for data that provides coordinates. Like this. Okay. Also, something that's really typical for your slope is that your numerator, and this is really important, is change in measure. Thank you, ma'am. Is that my warm fuzzy? I love warm fuzzies. Over change in time. I'm not saying that that's always the case. I'm just saying that it's typical. Okay? Thank you. Okay, so something else to be on the lookout for. For this, look for this phrase. Express y in terms of x. And we need to know what that means. Y in terms of x looks like this. Y equals everything's happening to the x. Okay. We could also see it looking like this. Here's another phrase that's really, really common. Y is a function of x. This is another really common phrase. And it gives you many clues. So y is a function of x looks like this. The function of x is equal to mx plus b, where f of x is really your y. Y is a function of x, right? So you have to be on the lookout for that. Okay, so here we go. Let's take a look at the first problem. So the first time I'm going to read it. I'm going to see what little bits of information and data I can get out of it. And the one thing I need to do is I need to figure out what data represents my X and what data represents my Y. Otherwise, I might get my slope upside down, change in X over change in Y instead of change in Y over change in X. So let's read it. The amount of heat in joules required to convert 1 gram of water into vapor is linearly related to the temperature T in Celsius of atmosphere. At 10 degrees Celsius, this conversion requires 2,480 joules, and each increase in temperature of 15 degrees lowers the amount of heat needed by 40 joules. Express H in terms of T. What does that mean? Because that is my key. That's the thing that tells me what my Y is and what my X is. I'm just using different variables. Instead of X and Y, I'm using H and T. So how do I write that? H equals MT plus B. So what we have determined here is that when I'm going to define my variables now, I'm going to define what is my X and what is my Y. So what is my X? T. But what is T representing? Define it. No, look. It's temperature. So you know what I'm going to do? I'm going to underline that in red. So I'm going to define my X as my temperature. And what's my H representing? What? Heat. Joules is my measurement of heat. So now that we've defined what our X is and what our Y is, and that was really helpful to use that last statement to help us define that. Let's go back, and I'm going to go back with my red pen, and I'm going to find all my temperature data that I can. Okay, so I'll go to the second sentence here. It says at 10 degrees Celsius, this is a temperature, right? So I'm going to write that down here, 10. This conversion requires 2,480 joules. That's a heat. I'll look at that in a second. And then it says this, and each increase in temperature of 15 degrees Celsius, and what kind, should I be going up or down? Up, because it says increase, right? So that's a change in Y, plus 15. So I'm going to go like this. Plus 15 is what? 25. Okay, so I have a point, and now I'm going to create another data point right here. Because as I increase 15, that's going to take my temperature to 25. It's going to give me another data point. Now I'm going to switch to my heat color, my blue. Heat's red. I should have done my heat with red. Anyways, so let's go find my corresponding to 10 degrees Celsius is 2,480 joules, right? So there's my first piece of data for my heat. And then my second piece of data is what? Lowers by 40, so that means it's going down. So let's subtract 40 to get my other data. So if my temperature went up 15, my joules went down to 2,440. And look at that. I have 2 points. I also have slope. This sentence right here, this sentence right here tells me a change in X and a change in Y. It does, doesn't it? Think about what it says. It says my slope, which is a change in heat, right? Over a change in temp, right? And the sentence here in the bracket says as my temp goes up 15, what does my heat required do? It goes down 40. So that's a slope. And you can see it because look here. What's my change in my y? 40. What's my change in my x? Yeah. Well, negative 40 and 15, so there it is. So let's simplify that to negative 8/3. And now we have what we need, because we need a point and we need a slope. So here we go. H. Oh, but we're going to plug it in point slope. Can I change y to h? So instead of y minus y sub 1, I can do h minus h sub 1, or do you want me to leave it in point slope? I don't want to confuse you. Okay, let's take a consensus, and I'll do it the way you want. Do we want to leave it in point slope y minus y sub 1, or do we want to do h and t? Okay, h and t. So h minus 2480 equals my slope times t minus 10. I like that you're ready to make that transition into point slope. Then we'll distribute. So that's h minus 2480 equals negative 8/3 t plus 80/3. No, it's x minus x sub 1. So x minus 10. Okay, and then I'm going to move that over there, and I'm just going to give you the answer. H is equal to negative 8/3 t plus 2,506.6 repeating. And that, my friends, is H expressed in terms of T. So now I have created a situation where I can pick any temperature I want and plug it in, and it'll tell me how much heat is required. Or I can pick how much heat is required, and I can figure out what the temperature is. So it's really useful because now I can use it for whichever I want. Questions? So really important to recap. Always identify, write your equation. Figure out what is your x, what is your y. And then after you do that, actually define your x and your y in words. Your x is temperature, your y is heat. Okay? And then make sure you find your slope. Don't go to sleep. Here we go. We're going to do part A, and then we're going to stop for the day because I stopped there with all the other classes and I don't want to get ahead. So no homework. On Monday, we'll finish up the note page, then you'll work on the assignment. Okay, so here we go. Here we go. A baby orangutan weighs 10 pounds and is 19 inches long at birth. How cute, just like a little person. 3 years later, his weight is 30 pounds and his height is 37 inches. I have a feeling this is not true. I'm thinking maybe as a person that's true, but I think a 3-year-old orangutan probably weighs like 200 pounds. But anyways, we're going to go with it. Assume that the weight, W, in pounds and the length, L, in inches are linearly related to age, T, in years. Part A, express W in terms of T. So, how do I write that equation? And I don't want that pen. I don't want it. How do I write that equation? W equals M baby t, lowercase t plus b. That's right. So let's identify what is our x? Define it. T. What's T? Age or time, right? Age. Okay, we'll do age. Age. And what's W? Weight, right? So we're defining, that looks terrible. It looks like it says lage. I'm fixing that. I don't even know what that is. Okay, so age versus weight. Okay, let's go do the other side. It says express L in terms of t. Since they're linear related, that means my equation looks like L equals mt plus b. So in this, let's define. What's our x? The age, right? And length is your y. So if you can just get to that point, I think it's not so bad to start extracting your points. So since age is common in both, I'm going to go ahead and grab my green pen, and I'm going to go back to the problem, and I'm going to identify all of the ages that I can find. So here we go. Baby orangutan weighs 10 pounds and is 19 inches long at birth. What's its age? T equals 0. 3 years later, what's its age? Okay, and does it talk any more about age? Nope. Okay, so I've identified age. So I know that over here I'm going to have a 0 and not another 0. How about a 0 and a 3? And over here, my age is going to be 0 and 3 because I'm just defining as I go. Now I'm switching colors. I'm going to go grab my red. And I guess let's go back and find weights. Let's go find all the weights. So what weight goes with 0 at birth? 10 pounds, right? So that's my weight is 10. And then 3 years later, his weight is 30 pounds. So that's another one. So at 0, he was 10 pounds. And at 3, he was 30 pounds. He must have been little for an orangutan. Then I'm going to go grab my blue pen and I'm going to grab my other information. Here we go. So we have the age. Let's get the length for age 0. What's his length? A little short guy. And then 3 years later, his length is, well, now he's a height because probably he's standing up, but there you go. Okay, so listen, we have points. We also have something really nice that didn't exist in the last problem. And it's this point right here and this point right here. It's a very specific point. Does anybody know what it is? Yeah, it's the y-intercept. Do you know that means I can go straight to slope-intercept once I know the slope? Yeah, because this is your y-intercept. So maybe because of that 0, you can avoid point slope, which is nice. You can avoid it. So let's find our slope here. So our slope is our change in weight over our change in age. I think that was a T, right? W and T. I'm going to clean that up because that looks terrible. Right, our change in weight over our change in time. So what's our weight change? I think you can see it. 20, right? It went up 20 when the age went up 3. So there's our slope. And we have our slope and we have our y-intercept. So we should be able to write our equation. W equals 20/3 t plus 10. So a nice little benefit of recognizing the y-intercept is that you can avoid the step of plugging it into point slope. Of course, you could plug it into point slope and you'll see how quickly it changes. How about you guys do the last one? And I'll press pause. And so press pause if you're watching the video and do it, and then press play to see if you got it right. There you go. You should have found your change in length over your change in time, found your slope, which was 6, and then plugged it into your equation with your slope and your y-intercept. And there you go. We're going to stop there for today, and we'll pick up and finish the notes on Monday.